So we are doing that VSWR. We will be concentrated on that one today. VSWR, voltage standing wave ratio. Before going to that one, what we left, that I'm discussing. That I told that you will be getting some Z max when Vmax is there and I mean is there. Already I told in the last class that whenever your maximum voltage will occur, same point your minimum current will be there. And minimum voltage, maximum current. Very simple. So when this Z will be maximized, when current is minimum, voltage is maximum. But in physical Ohm's law or something, what we know, V is proportional to I. But here we are getting opposite things. That is an interesting observation that I told. And phase difference is also zero. Uh, we are not assuming any phase difference, and it is a real quantity. So instead of Z max, we can write R max also. It's purely real quantity. eh? So same thing. It is V max by I max, right? And it is nothing but Z naught 1 plus mod of gamma L and 1 minus gamma L. That you can check. Already we have discussed in the last class. Similarly, your R mean will equals Z mean is equals to R mean. It will be what? V mean divided by I max. Mod of that one, mod of that one. So it will be coming Z naught. This will be reverse 1 minus gamma L mod 1 plus gamma L. And why it is so? You can easily see if gamma L is almost equals to 1, it will be what? It will tends to infinity. An interesting observation again. Gamma L is 1 means what? Your full reflection. When it is 100% reflection, then your Z max is almost infinite. Maximum you are getting. And here, when full reflection is there, then that's why it is called Z mean. Z mean. So it will be 0. Okay. I think it is quite clear. And what is voltage standing wave ratio? That is already there in the notes. So what is VSWR? It is represented by rho. It is nothing but Vmax by Vmin. And if you remember today's class also, VSWR we have done in reflection. It is nothing but Emax by Emin or Hmax by Hmin, I told. So same thing here also. So Vmax is nothing but V plus, and it will be 1 plus gamma L, and Vmin will be minus 1 minus gamma L. So anyhow, this will be cancelled. So rho will be getting 1 plus gamma L, 1 minus gamma L. Today also we have discussed the same thing. Same results we are getting. If you remember, same thing we are getting. Correct? So we know that gamma L is what? It is nothing but ZL minus Z naught divided by ZL plus Z naught. Please revise or continued. If you just see, so it will be what? 1 plus ZL minus Z naught, ZL plus Z naught divided by 1 minus ZL minus Z naught by ZL plus Z naught. Correct? So what it will be coming? ZL and ZL. So twice ZL divided by It is coming ZL and minus, so twice Z, something like that. If you substitute. And another thing, what we can say, gamma L mod of this one, we know that this is less than 1. This results already you know, right? Now we will be discussing some of the characteristics of this reflection coefficient and VSWR, what we are getting. VSWR we can easily do from this expression. Once we get this gamma L, we can easily substitute and get this VSWR. It is easy.
Sir, can you repeat that mod of gamma L less than or equal to 1?
This is almost we have discussed in the last class, same thing. It should be within 0 and 1. It will be
Oh, okay.
coming like that. Just I am writing. It should come between 0 to 1, but what it will coming 1. You can see from here also. Because if it
Yes,
is
sir, it should be between 0 to 1.
if it is a complex quantity, obviously this j and root over this square plus this square, it will be coming 1. What either it should be coming 1 or maybe less than 1, but it should not be greater than that. Why? Quite simple, na? Because ZL minus Z0 is there. So it's either it will be 1. When it will be 1? When ZL is equals to Z0, it will be 0. When Z0 is when it will be 1, when Z0 is 0, like that. I'm coming
Yes, sir.
like that.
And this is reflection coefficient, no, sir.
Yes, that's
Okay.
reflection coefficient. This is VSWR. Some problems will be coming from here only. Please concentrate on that. VSWR and reflection coefficient. In gate level also, it is very important formula. 100% so many questions are there. Now we will be discussing some of the cases. Case 1, let's say it is there in the syllabus. If it is given, line is short-circuited. Short-circuited at load end. At load end it is given. Line is short-circuited. Load end means in this load it is short-circuited. Correct? Let's say this is the generator in the load line. This is short-circuited. Yes. This is the generator. So what will happen if from the generator some voltage will be going here, it will be reflected, or what it will happen? Look here, very simple. Load and short-circuited means ZL should be 0. What will be your gamma L? It will be ZL minus Z0, ZL plus Z0. Very simple. It will be minus 1 because ZL is equals to 0. Now mod of gamma L is coming what? Please remember this one. Modulus anyhow, it is coming 1. But reflection coefficient is coming minus 1.
Sir, minus indicates what, sir?
Minus indicates, actually, if it is plus, it will be 100% reflected back. But it is not like that. It will be going and it will, what I can say, actually, we are representing by some phase and some angles, right? So this is the magnitude and phase.
Yes.
So phase will be 180 degree.
But if gamma L is 1, then it will be 0.
No. Gamma L is minus
I
1.
mean phase.
Yes. So gamma L is what? Mod of gamma L, and some angle will be there, phi of L. So
Correct, sir.
minus means it is 180 degree. Your reflection.
So if it was positive 1, gamma phi L would be 0.
Same direction actually. Yes, 0 degree we can say.
Then shouldn't it pass in the same direction?
It is going in the same direction we can say. Means opposite direction is not there. It is reflected, but it is
Okay.
in the same direction.
Okay.
So this is your case one. But whatever analysis is there, you remember in the form of mod of that one. Anyhow, we are
Sure, sir.
getting plus of 1. When magnitude, we are getting plus of 1.
Sir,
Yes.
if phi L is 0, wouldn't it be the same as transmitted?
If file, no. File is 0 means what? Reflection. If reflection is 0, then only what we can say, whatever it is going, it is going to the transmitting end. There is no reflection. But here reflection is there. Means reflection is there. There is no transmitted end. We are doing some lossless transmission line and all. Transmitted wave is not there. Just I'm telling that the phase is 180 degree. That we are getting.
Okay.
Not the transmitted wave. If phi L is 0, then only we can say that reflection is not there. Now case 2. If the line is open circuited. If the line is open circuited. Now what is the meaning? Open circuited means the load line, it is open. I'm not drawing that one. This is open circuit. Then what will happen? ZL is nothing but infinity. We know. So gamma L is nothing but ZL minus Z0, ZL plus Z0. So it will be tending to infinity. So how we will do? We can write Z0 by ZL. Can we write like that? When ZL tends to infinity. So this will be 1. Because 1 by infinity is 0, 1 by infinity is 0. So here also mod of gamma L, we are getting 1. For both the cases, we are getting full reflection. When a full strength of reflection we are getting. If the line is short circuited, if the line is open circuited, both the cases. Third case also there. What is the third case? Let's say ZL is terminated some ideal reactance. Case number 3. Case number 3. Load is terminated at ideal reactance. What will happen? Ideal reactance means ZL is, we can write J into X, some pure reactance. What it will come? Some phase is there and some pure reactance value. So gamma L is what? ZL minus Z0, ZL plus Z0, JX minus Z0, JX plus Z0, correct? Now, what will be your mod of gamma L? That's I'm telling. Always you do in terms of absolute value. So mod again, it will come 1. Why? Because J and all, let's say, it will be X square, again this some plus Z square, again this is plus. So again, it will be coming 1. Both are coming 1. So what we are getting? We are getting full reflection. It doesn't make some sense if it is open circuit, if it is short circuit, or ideal reactance. It can absorb the power, but we are getting the full reflection. So my conclusion is we are getting full reflection, 100% reflection. Gamma L is 1 for open circuit, short circuit, or ideal reactance. For all the case, we are getting full reflection. So one question may come like that. Comment on the reflection coefficient, or they can say if the load is terminated at some ideal reactance, or maybe or if it is open circuited and short circuited, what it will happen for your reflection coefficient and your VSWR. Acha, VSWR, what is the formula? You can easily tell. It is not there in the notes, but it is nothing but where I have written this one. You can easily place and you will get the value. So all the cases it is 1. So VSWR is almost infinite. That is beauty. It is coming infinite. Now I am coming for that one also. Let's say some bounds of VSWR. What are the bounds on VSWR? Reflection coefficient we already know. Bound is this one. That we know. Now what is the bound for rho? Rho is nothing but 1 plus mod of gamma L, 1 minus mod of gamma L. Please remember this formula, like Maxwell's equation. Same thing. Now, if mod of gamma L is 1, then obviously VSWR is coming to infinity. Now, if gamma L is 0, then VSWR is coming 1. Okay. If mod of gamma L is 1. So the bounds are nothing but between 1. Look here, for 0, it is coming what? 1. For 1, it is coming infinity. So what will be the bound now? Rho, not mod of that one. Rho is between 1 to infinity. I'm rubbing this one. Please remember. So these are the boundary for the VSWR. Between 1 to infinity. Now, which one is good and which one is bad? That also we need to know. As we are going for some higher and higher value of rho, what is the meaning? Higher and higher value of rho. The meaning is reflection value will increase. Look here. I am writing here only 0, gamma L greater than 1, like that. So higher value means rho, from rho 1 to infinity. We are moving. So your reflection will move from 0 to 1. And when it is infinity, full reflection, 100% reflection. So our approach will be to reduce the VSWR as low as possible. Because already I told in the last class, reflection is not good. 100% reflection means there is a mismatch in the transmission line. So we need to remove, or we need to search for the lower value of VSWR as much as possible. And our idea is to minimize rho, or we can say minimizing rho means minimizing this gamma L also. Same, because all are directly proportional. So we need to minimize VSWR as much as possible, so that our mismatch on the transmission line will not be there. And we need, what is the perfect condition? Whatever incident, it will be going to the transmitter end. Incident and transmitter. So there will be no reflection. That is our aim. And the meaning is VSWR should be as low as possible. And our ideal case is VSWR should be 1. Okay. Any confusion up to now? Very slowly I am going. What is VSWR? Right? What are the bounds of VSWR? And what are the cases if the line is short circuited, open circuited, terminated the ideal reactance? All are very important for your CIE. What one question will come for VSWR? May 1 or 2 questions may come like that. some numericals may come. Find VSWR if reflection coefficient is given like that. You can search in the internet, and anyhow, I will share later. I didn't frame some problems. Acha, in the tutorial, you will get some problems. You please solve that one. I think some problems are there in the tutorial. That may be important in CL. You solve that. Another formula may come, just repetition I'm telling. Here also I can write where I've written Rmax and all. Here also I can write. That will be good. Rmax is nothing but this one. And what is your VSWR? Check. What is the formula? This one, 1 plus gamma and 1 minus gamma, correct? So here you can write what? Z naught into rho, correct? And here you can write Z naught divided by rho. This is your R mean. So some question may come like that also. Find Rmax when characteristic impedance is given, rho is given. So many problems can be framed. If you know the formula, so many problems you can solve by knowing rho, Z naught, lossless transmission line, and lossy is not there, distortionless is not there. That is good. But maybe some problems are given to find Z naught. From there, you will be getting rho from Rmax. So please memorize all the formula. And in white paper, you write all the formulas. That will be good for all of you. Now we will be doing impedance transformation for lossless transmission line. Another important term. Impedance for lossless. Fortunately, only lossless is there. Otherwise, everything you have to do for lossy and other distortionless, so many are there. So really, it will be very hectic and tough. Okay. This formula already I told. You referred the previous notes. ZL sine hypotenuse gamma L plus Z naught sine hypotenuse gamma L divided by,
Sir, that
sorry,
is hyperbolic.
1 second, I have written some wrong. This will be cos, correct, na? This will be cos, this will be sine. Again, opposite. Z naught into cos plus ZL into sine. Okay. Now from there also you can write in this form. Today also I told. Oh, Zoom has some problem. That is ZL plus Z naught into tan hypotenuse gamma L. That also in the some books are there where it is written in form of tan. So don't get confused. You can write in this form or in this form also. Now what is ZL bar? That also I told it should be normalized with respect to Z naught. So it will be ZL bar. Can I write in this form? ZL bar plus tan hypotenuse gamma L plus 1 plus ZL bar tan hypotenuse gamma. It is coming like that. You please check from this equation. Z naught will go here. It will be ZL bar. And this will be ZL bar. This is correct. Just we have normalized with respect to Z naught. Okay. Now, if, please concentrate. ZL bar is 1. What is the meaning? ZL is nothing but Z naught, means matched condition, nothing but that one. Then ZL bar also will be equals to 1. Z of L is equals to Z naught. Then what will happen? And what will happen for lossless transmission line? We need to develop this equation in respect to lossless transmission. One second. Another page. Okay. For lossless we are doing. So lossless means what? Gamma is alpha plus J beta. Already I told it is nothing but J beta since alpha is equals to 0. So replace all the equation where gamma is there with J beta. Now, if you can anyone tell me cos hypotenuse gamma L, it is equals to cos hypotenuse into J beta L. So what it will come? If you analyze hypotenuse, let's say cos hypotenuse gamma L. Please concentrate. It is nothing but e to the power gamma L minus e to the power minus gamma L divided by 2.
Plus one, plus.
No,
Plus one,
this minus this. This is correct.
sir, cos.
Okay. Plus, na? Yes. This will be plus. Correct. If it is cos hypotenuse into J beta L, then what it will come? E to the power into J
Cos.
beta L plus e to the power minus J beta L divided by 2. It is nothing but your cos beta L. Correct? Cos beta L it is.
Yes.
So this we can write as cos of beta L. Similarly, sine hypotenuse gamma L, we can write as, you can check, J into sine beta L. Why J will come? Because another thing you need to multiply. From there, your J term will be there. Okay. So to multiply with J to make it 2J. So please replace the equations. What we are getting, ZL bar is equals to, let's say we are getting ZL bar into cos hypotenuse gamma L plus it will be sine hypotenuse gamma L divided by cos hypotenuse gamma L plus, one second, what I got. Not this one.
Yes.
Yes.
Sir, yes. Plus
ZL bar
ZL bar.
cos, then it will be cos and ZL bar. Okay. Cos and ZL bar, correct. Sine hypotenuse gamma L. So we are replacing this as ZL bar cos this one, cos beta L. And this will be plus J into sine beta L cos beta L plus ZL bar into J into sine beta. Like that it will come something. Correct. Okay. This is one equation. Now, what is our idea I am telling? In the next page, some interesting observation will come. Some characteristics we need to do. 3 cases. First case is, let's say, impedance value repeats after lambda by 2 distance. This is a statement, but we need to prove. First, we need to do at location, at some location L, we need to find the impedance is equals to what? Z of L. But my argument is it repeating after lambda by 2 distance? This is the wavelength. So after 50% of the wavelength, is it repeating the same value? Can we prove that one? How to prove? It will be what? ZL plus lambda by 2. Very simple. Whatever equations we are getting, you write L plus lambda by 2. Like in periodic signal you do. This plus pi or this plus 2 pi, is it repeating like that? Already you done that things. So all these things we need to write with respect to L plus lambda by 2. So it will be coming ZL bar cos beta into L plus lambda by 2. Again, this will be plus J sine L plus lambda by 2 into beta. Correct? Whatever will be divided by cos of beta L plus lambda by 2 plus J ZL bar sine L plus lambda by 2 beta. Now, what is the meaning of this one? Beta L plus lambda by 2. Beta is what? 2 pi by lambda. You simplify. L plus lambda by 2. What it is coming? 2 pi L by lambda plus this one lambda cancel. This is pi. So 2 pi L by lambda. What is the meaning? This is nothing but beta into L plus pi. Is it clear? So L plus lambda by 2, we are getting as beta L plus pi. I think it is clear. Then you substitute where L plus lambda by 2 with beta L plus pi. You will get the answer. 1 second. So you write.
1 second, can you go back?
All of you connect 1 second. 1 minute is there. Okay, you concentrate on that one. Just this pi and pi, lambda will cancel. It is coming 2 pi L by lambda. It is nothing but beta into L. And this pi will come. So beta L plus pi.